Okay, so in the probability, we're going to generally be looking at what's known as trials, okay, where we might have a trial where we toss a coin or we throw a dice, and we'll be considering the possible outcomes given the trial. So if we were to toss a coin, there's only two outcomes, heads or tails, or if we throw a dice, there's six outcomes, like a 1 or a 2 or a 3 or 4 or 5 or 6, okay? And where there are only two possible outcomes from a trial, then we say that each outcome has an evens chance. But if there's more than two possible outcomes from a given trial, then we say that there's more than two possible outcomes, but each have an equally likely chance. When we throw a dice, it's equally likely that we'll get a 1 or a 2 or a 4 or a 5 or a 6 or a 3 or whatever. So a little bit of terminology there. The trial is actually what we're doing. Considering each trial, then there's possible outcomes, and we're looking at the probability of which outcome is likely to occur. And throughout the probability in junior cycle and senior cycle, we'll see that we'll perform these different trials with possible outcomes, and we might generally perform them at the same time, or there might be cases further down the line where we perform them in sequence one after another. But for now, let's look at the fundamental principle of counting, okay? And let's say we hold two trials at the same time. So we toss a coin and we throw a dice. The number of possible outcomes from tossing the coin with its heads or its tails, or throwing the dice with its numbers 1 to 6, the total number of possible outcomes is 2 times 6 is 12. So we're multiplying the possible outcomes from the coin by the possible outcomes from the dice, and we get 12. And if we were to list them, the possible outcomes, we could toss the coin and throw the dice and get a heads and the number 1, or a heads number 2, 3, 4, 5, 6, or we could get a tails and a 1, a tails and a 2. These are all the possible outcomes from tossing the coin and throwing the dice. And this list is known as the sample space, okay? And, we can also consider the trials of sitting in a restaurant where we have the menu in front of us, and we've two trials. The first trial is that we have to pick a starter from two possible outcomes, and the second trial might be that we have to pick a main dish, and that's has three possible outcomes. So the total number of possible outcomes, different types of meals we can sit down and have, given that we have one starter and one main, are 2 by 3, two starters by 3 mains, 6 possible outcomes. And if we were to list those, we would be giving the sample space, like a soup and a salmon, or a soup and a steak, or a soup and a fish, or a melon and salmon, melon and steak, melon and fish. And then we'll move on now to look at more terminology. Okay, so there's this notion of a favourable outcome or an event. They're one and the same thing, really. A favourable outcome is the outcome you want. Like if you were to toss a coin and the favourable outcome, the one you want to be heads, then that's your favourable outcome, or that's the event you're looking for, the result you want. Okay, so we're going for a trial which yields equally likely outcomes, tossing a coin, throwing a dice. We're going to use this formula, which tells us that the probability of the event, or the desired result, or the result you want, the probability of that happening in this trial is found by the number of favourable outcomes divided by the number of all the possible outcomes in the sample space. So the number of favourable outcomes is how many times the result or outcome you want, or the desired result, whatever you want to call it, appears in the sample space of all the possible outcomes. So if we were to throw a dice, that's our trial, and if we want an even number, that's the event or the favourable outcome we're looking for, then the probability P, and in brackets we write the event, even number, is equal to the number of even numbers in the sample space, okay, divided by the number of possible outcomes. So in the sample space from throwing a dice, it's 1, 2, 1, 2, 3, 4, 5, or 6. They're all the possible ones. The number or even numbers can occur 3 times in that sample space of 6 possibles. So our probability of an even number using the formula is 1 in 2. So let's look at finding the probability for a given event, and in this case, or given events, 2 events in this case, that we have 2 trials on the go here now. We're going to toss a coin and throw a dice, and we know from the possible outcomes of the coin there's 2, heads or tails, or the dice there's 6. So our sample space would contain 2 by 6, 12 possible outcomes. Here they are listed. Okay, and let's look to see now to find the probability of a head and an even. So in our sample space, we'll just look at the heads here, and the evens 2, 4, 6. So there's 3 of those divided by 12 in the total space. That gives us a probability of 1 in 4. Let's look at the probability of a 1 and a tail. So we'll just consider the tails here, and there's the 1 and the tail. Out of the 12, it's 1 and 12. A head and a number less than 5, so less than 5, so it's this one, this one, this one, this one. So there's 4 possible favourable outcomes out of the total sample space of 12, so that's 1 in 3. Now, just whilst we're here with this and, we have the probability of a head and an even number, and we've seen that that's equal to 1 in 4. Okay, and now we have this in probability, we have this multiplication rule where we can simply multiply to find the probability of head and an even number. We can simply multiply the probability of the head by the probability of an even number. Okay, and it should give us 1 in 4. So the probability of getting a head from the sample space, the 6 of those in 12 is 6 over 12, multiplied by the probability of getting an even in the sample space. Well, there's 2, 4, 6 of those in 12. So that's the same as 6 over 12 is 1 over 2, by 1 over 2, that's 1 over 4. Okay, and you can see that by multiplying the probability of a head by the probability of an even, a head and an even, multiplying the two using this thing known as the multiplication rule, we get the same answer, that the probability of getting a head and an even is 1 in 4. We found it up here by just simply analysing the sample space, and we found it down here using the formula, the multiplication or AND rule formula, which you'll meet as you go up the line. Now, third example, a bag contains 10 counters, 5 are blue, 5 are red, 2 are white, and 1 is green. So our sample space, our possible outcomes, if we were to put our hand into the bag and pick a counter out, we have 5 blue, 2 red, 2 white, and 1 green. So what's the probability of finding a red? Well, there's 2 reds in 10, so it's 1 in 5. And the probability of picking out of the bag a blue or a red, so we've 1, 2, 3, 4, 5, 6, 7 out of 10, 7 in 10 chance. And then let's look at the probability of pulling a ball out of the bag that's not white. Well, it must be any one of these 8 in 10, so that's 4 in 5. And just while we're here, I just want to come back to this for one moment. It's something you'll meet as you go up the line again, but it's worth just a little mention now. But if we see that we're looking for the probability of a blue counter or a red counter. Now we found that by looking at the sample space that it was 7 over 10. But we can also use a formula known as the OR rule, or the addition rule, again, which we'll meet later on. Don't worry about too much now, but it's nice to see how it works. But the OR rule says that the probability of a blue or a red is equal to the probability of a blue plus the probability is the addition rule of a red. And the probability of a blue is 5 over 10. And the probability of a red is 2 over 10. And that's equal to 7 over 10. Just something to worth noting for we're going to meet it in the future. And finally, we'll just mention the probability scale, which probability of something to happening, the likelihood of an event happening, goes from 0 to 1. Okay, and we can say that's decimal 0 to 1, so we have 0.25, 0.5, 0.75, or as percentages 0, 25% likely to happen, 50%, 75, 100% likely to happen, and in words, 0 is impossible, 1 is certain, 50% or 0.5 is an evens chance, 0.25 can be considered to be unlikely to happen, 0.75 is likely. So the likelihood of an event to happen can be considered using the probability scale, the likelihood that Saturday will follow Friday is certain. The likelihood or the probability that Sunday will follow Friday is impossible. And often if we were to say that the probability of some event was to happen was equal to 0.6 or 60% or whatever, then the probability of it not happening would be equal to 1 minus 0.6, and that would be 0.4, okay, for it not to happen.